Good morning to all. I am Subharani, Associate Professor, Emmanuel Rasa College of Pharmacy. Today's topic is classification of organic compounds. So, the organic compound, any of a large class of chemical compounds in which one or more atoms of carbon are covalently linked to atoms of other elements, such as the elements are hydrogen, oxygen, or nitrogen. So, that is known as organic compound. Next, the classification of organic compounds. The organic compounds are mainly classified as two forms. First one is open chain or acyclic compounds. Then second type is closed chain or cyclic compounds. The open chain or acyclic compounds are example is alkane and alkene. Alkane. What is alkane? The general form of alkane is CnH2n plus 2. So, methane, ethane, propane, that is known as alkane. The single bond is known as alkane. Then alkene is the double bonded compound. So, methane, ethene, propene, butene is known as alkene. That is alkyne. Alkyne is known as CnH2n minus 2 is the general form. The example is ONE. Ethine is known as alkyne. The next, the closed chain or cyclic compound is separated in two forms, that is known as homocyclic and heterocyclic. The heterocyclic compound is known as, examples are furan, pyrrole, and thiophene. That these are also known as aromatic compound. Then the homocyclic compounds are subdivided into two forms, that is known as alicyclic and aromatic compounds. Alicyclic compound is examples are cyclopropane, cyclobutane, cyclohexane, etc. Then aromatic compound is known as benzene ring compound. Then aromatic compounds are subdivided into two forms. That is, one is benzenide and another one is non-benzenide compound. The benzenide compound examples are benzene, naphthalene, anthracene, etc. The non-benzenide compound examples are tropolane. First, the open chain compounds are acyclic compounds. The carbon atoms are present in the form of an open chain is known as open chain compound. This can be maybe either straight line or branch chain. They are initially known as aliphatic compounds because the compounds of this class were derived from either animal or vegetable fats. The next, straight chain compounds. The carbon skeleton is in the form of straight chain is known as straight chain compounds. Example, propane, CH3, CH2, CH3. It's known as propane. Then next, branch chain compounds. The carbon skeleton is in the form of branch chain. Example is isobutylene. The next, cyclic or closed chain compounds. They are marked by the presence of one or more closed chains of rings of atoms in their structure. They are depending in whether they are in the presence of any other atom apart from carbon is the continuation of the ring. They are further subdivided into homocyclic or carbocyclic compounds, then heterocyclic compounds. So, homocyclic compound or carbocyclic compound. The rings in these compounds are entirely made up of carbon atoms. No other atom is present in the ring skeleton. So, homocyclic compounds only made up of carbon atoms. There are no other atom is obtained. There can be further divided into two classes. They are alicyclic compounds and aromatic compounds. So, next, alicyclic compounds. The name is attributed to their resemblance of aliphatic compounds in their properties. So, the example is cyclopropane, cyclobutane, cyclohexane, etc. The next one is aromatic compounds. These are cyclic or unsaturated compound. So unsaturated or saturated is known as, then saturated compound is known as single bond, carbon carbon single bond, that is known as saturated. So unsaturated compound is known as carbon carbon double bond or triple bond. Okay, then they are cyclic unsaturated compound. They derive their name from the Greek word aroma, which means fragrant smell. Since most of the compounds bear a pleasant smell, that is, these compounds are known as aromatic compounds. The aromatic compounds are further classified into two types. So first one is benzenide aromatic compound, then second one is non-benzenide aromatic compound. Then benzenide aromatic compound, they are characterized by the presence of one or more fused or isolated benzene ring, as well as their derivatives in their structure. So benzenide compound, at least one benzene ring is obtained, okay, depending upon the number of benzene ring that are fused together in their structure. The benzenide compounds are further classified into monocyclic, bicyclic or tricyclic. So first one is monocyclic. Monocyclic means one benzene ring is obtained, okay. They are characterized by the presence of a single benzene ring to which other groups are attached. For example, benzene, toluene. In benzene ring, which one CH3 group is obtained, there is known as toluene. Then orthosilane, two CH3 group, two alkyl group is attached to the benzene ring, that is known as silene, orthosilane. Then one CH3 group is obtained in ortho position. Then metasilane, one CH3 group is obtained in meta position, so known as metasilane. Then parasilane, one CH3 group is obtained in para position. So these are examples of monocyclic compounds. The next one, bicyclic or tricyclic compound. These are characterized in the presence of two benzene rings are attached, that is known as bicyclic compound. Then three benzene rings are attached, these are known as tricyclic compound. For example, bicyclic compound example naphthalene, and tricyclic compound is example phenanthracene and anthracene. Okay, next, non-benzenide aromatic compound. These aromatic compounds that contain other highly unsaturated rings in place of the benzene ring are called non-benzenide compound, non-benzenide aromatic compounds. The non-benzenide aromatic compounds, so that is known as unsaturated compound. Unsaturated compound, that means double bond or triple bond is attached. Okay. The next, heterocyclic compounds. When one or more heteroatoms such as oxygen, nitrogen, sulfur, boron, silicon, etc. is one or more heteroatoms attached to the benzene ring is known as heterocyclic compound. Okay. A presence in the ring, such compounds are known as heterocyclic. One or more heteroatoms are attached to the benzene ring is known as heterocyclic compounds. That is known as heterocyclic. Okay, alicyclic or alicyclic heterocyclic compounds. Then aliphatic heterocyclic compounds that contain one or more heteroatoms are present. The rings are called alicyclic heteroatoms. Aliphatic heterocyclic compounds contain one or more heteroatoms. For example, tetrahydrofuran, tetrahydropyran, etc. Then aromatic heterocyclic compounds. These aromatic heterocyclic compounds that contains one or more heteroatoms in their ring skeleton are called aromatic heterocyclic compounds. So aromatic heterocyclic compounds that contain one or more heteroatoms. For example, the heteroatoms sulfur, nitrogen, etc. Okay. So that is the classification of organic compounds are completed. Okay. The main classification of organic compound is two types. First one is closed or open. Okay. Closed or open. Then closed compound and open compound. That the open chain compound or no closed chain compounds are further classified in two types. Then homo and hetero. The hetero is further classified into two types, that is alicyclic and aromatic. Then aromatic is further classified in two types, that is benzenoid and non-benzenoid. Okay. Okay, thank you students.